So we started this example for drawing the triangle out and finding its area here. So let's finish this up here. So we know how to find the area of a triangle. The area of a triangle here is 1/2 the base times the height, or the base times height divided by 2. So now we just have to find our pieces here. So our base here, we can just count from A here to B. So 1, 2, 3, 4, 5, 6, 7, 8. So area here is 1/2 the base. And then the height, it has to be from the base down here up to the very top of your point there. So our point there is at -4, 4. Oops. Goes there. So we're going from that point, which is right here, and we're going to drop it down to the base. And then we're just going to count that. So 1, 2, 3, 4, 5, 6, 7, looks like. So going from A there to C there, definitely 7. So this is 8, and that is 7. So 1/2 times 8 there is 4, and then times 7 is 28 square units. So that's how you find the area of a triangle, and I would just count them. It just makes it really easy. The Pythagorean theorem, if a triangle is a right triangle, then the square of the hypotenuse equals the sum of the square of its legs. The converse of Pythagorean says if the square of the hypotenuse equals the sum of the square of the legs in a triangle, then that triangle is a right triangle. We're going to use the converse of the Pythagorean theorem today to do some showing that something is a right triangle. So if we can show that the square of the hypotenuse equals the sum of the square of the legs, so in other words, if we use this Pythagorean theorem and it holds true, then that triangle is a right triangle. We can make that conclusion. So we're supposed to show that triangle HIJ is a right triangle. So we're going to use that converse to the Pythagorean theorem. So basically, we're going to go ahead and end up using the Pythagorean theorem on this. So let's graph this out here first. So -3, -4. And 3, -2. And then -5, 2. We're going to connect those dots. I didn't do a very good job there. So this here ends up being H, this here is J, and this here is I. So to me, it's looking like this over here, I'll bet you, is the right triangle, but the right angle over here, but you know, we got to show that that's true. So I'm going to use this as my A, and this is as my B, and this here is my C. So I want to figure out what the distance from HI is, what the distance from HJ is, and what the distance from JI is. Because if I do, then I can take HI squared plus JH squared plus JI squared, and that will end up giving me the solution. So I want to find the distance from HI, the distance from JH, and the distance from JI. And these here, the ones I'm starring here, these are your A and your B. So let's find those. Distance from H to I. So what do we do to find the distance? We go ahead and we subtract our values here, so our x values. So for HI here, I'm going to take 3 minus a -3 squared plus -2 minus a -4 squared. So 3 minus a -3 becomes 3 plus 3, which is 6. If I square that, I get 36. And then plus -2 minus a -4 becomes a minus, and there becomes a plus. And so I'll put those in there. we end up getting 2 squared, which is 4, which ends up giving us the square root of 40. And I wouldn't break those down at this point, just leave them like that because we're just going to square them later anyways. All right, so let's go to the next one, JH here. Same thing. So J to H here, so we're looking at the x values there. So we've got -5 minus a -3 squared plus 2 minus a -4 squared. So again, we got these minus goes on here, so go ahead and put pluses on there. -5 plus 3 there is -2. If we square it, we get 4. And then that 2 plus 4 there is 6 squared is 36. So we end up getting the square root of 40 again. All right, let's do JI. This is our C. This is our hypotenuse. So J to I there, we're going to go ahead and look at our x values here. So we're going to do -5 minus 3 squared plus y's 2 minus a -2 squared. So we only have one minus a minus there this time, so we're going to go ahead and make that a plus. And so now I get -5 minus 3 there is -8. If I square that, I get 64. And under here, 2 plus 2 there is 4, and I square that, I get 16. Add these together, and we get the square root of 80. Now, let's use the Pythagorean theorem. Pythagorean theorem says what? A squared plus B squared equals C squared. So we can put our values in there. Our HI there is the square root of 40 squared plus, we've got JH there, and that is our B there, so that is square root of 40. And we're trying to show that that's equal to the square root of 80 squared. So if you look at that, remember squared and square root undo each other there, so that square root of 40 squared there is 40. Square root of 40 squared there is 40. And the square root of 80 squared there is 80. So 80 does equal 80. So that does check. So therefore, we can conclude that HIJ is a right triangle. We just showed that to be it. We went through the Pythagorean theorem. We used the Pythagorean theorem there, and it held true. Therefore, we can conclude that it is a right triangle there. So then the next part down here actually said that we need to go ahead and show the area, find the area. So our area is equal to 1/2 the base times the height. Well, our base here is HI. The height there is from J to H there. So we can go ahead and just plug those in there. We can go 1/2 times the square root of 40, because that's what HI there is. That would be our base. And since they're a 90-degree angle, those are our base and our height. Square root of 40. So we get 1/2. We can actually multiply the square root of 40 times the square root of 40 is the square root of 1600. And of course, the square root of 1600 there is 40. 1/2 of 40 there is 20 square units. So we found the midpoint of a line segment, we found the distance between 2 points, we found the area of a polygon, and we showed that a triangle is a right triangle. So your assignment is there on Schoology for You.